Assalamualaikum warahmatullahi wabarakatuh, and good morning. In my side, it's morning already. Okay. Uh, all right. Today I want to share with you all, okay, with all the students, regarding the theories for X-ray diffraction, XRD analysis. Okay. So here my name. You can email me. You can contact me through WhatsApp or phone in order to help you, to assist you anything regarding the XRD analysis. Okay. Before I proceed further, okay, about my briefing today. All right. Maybe I want to ask you something. Okay. Um, let's say you have kids or siblings, or you itself is a twins, triplet, or quadruplet. Okay, so in this slide shows that these kids, okay, uh, they have a similar faces, they have a similar physical appearance, but how to differentiate them? Okay, how to differentiate them? Okay, so as you can see in the slide, okay, the best way to differentiate between these twins, triplet, and quadruplet. Okay, the best way is a fingerprints. Okay, so although you have a twins that exactly look same, but when you compare their fingerprints, okay, the patterns of the fingerprint is definitely different uh between the twins. Okay, so in this case, the best way to differentiate them is by using their fingerprints. Okay, uh, my next slide. Okay, I want to ask you. Okay, let's say you have four different kind of white powder. Okay, so and then you mix them together. Okay, and then let's say you have this one, two, three, four. These four plastic bottle contain white powder, and then you mix them. Okay, for example, I give you, okay, let's say the first plastic bottle contain calcium oxide, second is contain calcium carbonate, the third one contain calcium magnesium silicate, and then the fourth one contain the calcium hydroxide. Okay, this one, maybe you can identify it when you separate them physically. But what happen if you mix all this powder together? Okay, they have the same colors, all look same, the white powder, the how I say, the physical appearance is almost look similar, and then the particle size is looks similar. And now, let's say you mix them, and how you can identify in that mixture contain calcium oxide, calcium carbonate, calcium magnesium, calcium magnesium carbonate, and as well the calcium hydroxide. Okay, same I mentioned just now. Okay, in order to identify the mixture, okay, even this one you have twins, triplet, and quadruplet. They look same, but actually how to differentiate them? By their fingerprint. Okay, same goes also for this kind of situation. Okay, when you mix them, okay, how you identify those compound or oxide material, we need to identify their fingerprint. So therefore, uh, XRD come in. Okay, what is XRD? Okay, XRD is a versatile, non-destructive, quantitative, as well the qualitative. Okay, bear in mind, XRD analysis or measurement only applicable for crystalline materials. I repeat again, XRD only apply for crystalline materials. Okay, so what we get from XRD? Normally we get a phases compound present in powder and solid. samples. Okay. The second part, as you can see in my screen, okay, this was the modern computer method, automatic routine measurement, and by diffractogram. Okay, what is the diffractogram? Okay, this diffractogram produced when the light pass through the small gap. But in this kind of application for XRD, we're looking for the D value, or we call it as a interplanar spacing. Okay, so what is the interplanar spacing? What is the diffractogram? I will share with you later in the next slide. Okay, what is the ability of the XRD? Number one, XRD can measure what phases present in your material. Okay, I go back to this slide. Okay, in this slide, as I mentioned just now, when you mix those 4 samples in one container, you can identify this powder belong to calcium oxide, this powder belong to calcium carbonate. Okay, however, by using XRD, we're able to do that. So meaning we can identify which phases belong to calcium carbonate and which phases belong to calcium oxide using the XRD testing. Okay. Number two is at what concentration composition level. Okay. In this case, we are doing the quantitative analysis. For example, we want to know how much the calcium oxide has been added and how much the calcium carbonate has been added in the mixtures. So please remember, because this XRD analysis, you will use it start from the first year until your final year. Okay, normally in our school, XRD like a heart of the material science engineering. Okay, how does XRD works? The XRD pattern is often spoken as the fingerprint or DNA. So, as I mentioned before, even you have twins, triplet or quadruplet, we still can detect the difference by using the fingerprint or DNA. Okay, so again, XRD only apply for crystalline substance or compound. Okay, what is the crystalline material? Okay, so you need to find out the definition, the crystalline materials. Okay, when you have the fingerprints, for example, you have, as I mentioned before, the twins, the triplet and quadruplet. Okay, even though they have a look same physically, but actually, when you get their fingerprint, their DNA is different between each others. Okay, this one I think the best way how to explain the how the XRD principle works. Okay, I know each one of us have our own pattern of fingerprint. That's a beauty of Allah Subhanahu wa Ta'ala power. Okay, because each of you, even you get get birth by your mothers. Okay, your siblings, your sister or your brother, their fingerprint cannot be same as you. Okay, so that's why I think I want to give you simple examples. Okay, I think some of you fans of crime scene investigations shows in television, in internet TV. Okay, what happened if the crime occurs in that shows? Okay, the first thing that forensic need to find out is their fingerprint, because they know our thumbprint for each country in the world, they have their own database. So let's say if the crime occurs at the site, the first thing forensic need to find out is the how I say, the dead body, or the person who are involved in the in the crime. So they just take their fingerprints, put in the thumbprint machine, and then they scan the profile of the criminal. Okay, so same goes also in the XRD. Each compound, each oxide material, or each crystalline material have their own fingerprint. Okay, as you can see on top, this one the fingerprint of the human. But the below part, okay, the below part, let's say you want to measure this kind of powder, okay, and then when you use the XRD, you got this pattern. Okay, this one we call as a diffractogram. Okay, how to produce the diffractogram? In the next part of my video, I will explain how this pattern of XRD produced by using the XRD machine. Okay, I think that's all from my side. Thank you very much. Bye bye.